We have seen robots of various shapes and sizes all around us. But have you ever stopped and pondered, how do we actually define a robot? What constitutes a robot? And if you were to build your own, what are the factors you would have to consider? Today we are going to take a deeper dive into understanding what a robot is. So to ask the question again formally, what is a robot? If you would say that a robot is anything that can sense, anything that can interact with the environment. Technically, a washing machine does the same thing, right? A washing machine can sense the temperature outside to adjust the temperature of the water. The washing machine can basically adjust the amount of water level based on the amount of clothes you put in. Technically, it is sensing something in the environment and it's reacting to the way you want it in some sense, right? If you put in like only half the clothes, the timer is going to be reduced to something around half the time. So in my definition of a robot, would you think that is a robot? Some of you might say, no, washing machine cannot be a robot because it doesn't move. And the answer could be a yes or a no. It depends on who you ask. In my definition, I would say that a robot is an intelligent agent which can come in any shape and form as long as there is something in its entity which it can sense the environment and react back to the environment. It is a robot. Most of you might consider that the robot has to physically move, but that is not really a necessity that the robot has to be able to like physically move around or navigate to be able to be called a robot, right? Again, going back to my definition, a robot is an intelligent agent which senses the world through some of its sensors, and it can perceive the world, it can make sense out of what is going on around in the world for the specific kind of tasks it is supposed to manage. And then it can interact with the environment through some actuation modality, and that would be my definition of a robot. Most commonly, you would see robots of different shapes and sizes. This is the Atlas humanoid robot from Boston Dynamics from a few years ago. And this is a Parrot Bebop, which we have modified in our research. We call it the PRG Husky. And this is a Boston Dynamics Spot robot. It's like a quadruped leg kind of robot. If you have a chance to visit the Boston Museum, they have this under display there. And you can also have like a robotic arm, and you can take this robotic arm, put it on like a clear path Husky robot, which is like a ground vehicle sort of robot, which can do like an off-road kind of scenario. Again, going to more the definition again, a robot is an intelligent agent which resides in some environment of operation where it's desired to do or designed to do some sort of tasks. But environment had some other plans. It disturbs our robots. You might have seen these like videos from Boston Dynamics where like the person there is like kicking the robot or like disturbing the robot, pulling the box out of the hand of the robot. Or you might have seen these like drone videos or aerial robots flying in really hard conditions like dust, smoke, and wind. These are all environmental factors which we cannot control, right? And the robot essentially has to do its thing even despite a bunch of these environmental conditions. And so that we're saying that the intelligent agent lives in the environment but gets impacted by the environment itself, right? And then the robot again does something wherein it interacts with the environment again to be able to complete its task. For example, despite the wind, the aerial robot has to move to the location it desired to deliver your pizza or deliver like organs to a patient. It's gonna like move along in its direction, right? And so it has to push air in a particular way to be able to go forward or go left or whatever it needs to do. And in the Boston Dynamics robot example, the robot still has to be able to physically move around despite the disturbances and pick up the box despite the box being stolen from the robot's hand, right? To accomplish this, robots generally have a bunch of building blocks which are common, and roboticists have commonly described these functional modalities into three distinct blocks. The first one is called sensing, where the robot has a bunch of sensors like we have, and they can sense the world around them. Again, remember that these senses depend upon what you're trying to solve with the robot, and the senses can range from anything like a camera to something as simple as a temperature sensor for measuring the temperature of water in a washing machine, like we talked about before. Right? Once you make when you sense the environment, you realize that hey, like something is wrong, something needs to be changed, and so you really sit and think and ponder upon what that change is supposed to be, right? And this is what is called the decision making ability. For example, if the timer runs out on the washing machine example, you have to make a decision to like turn off the spinning and then basically then drain out all the water, and that could be the decision making process in a washing machine example. If it's a Atlas humanoid robot like we talked about before, the decision making could be as simple as hey, like I'm slipping, I need to move my leg in this particular way to be able to like be stable and not fall over, right? And a similar analogy for the drone example we talked about is that I need to change my motor speeds in this way so that like I counteract the wind which is coming from one side, so that I bump up the motors on the other side so that I don't really like crash into the ground or something like that. So once you've made that decision, you actually have to use that decision to enact and react to the world, and this is what is called the actuation. In the previous example, in the washing machine, spinning off the motors was the actuation mechanism, where how you spin, how you turn down the motors is the actuation modality. In the humanoid example, again, you change your joints in a particular way, and like these motors move, and that's actuation. Again, in the same example as the aerial robot, we say like we have to speed up or speed down the motors in a particular way to be able to actuate what we need, right? So just to recap again, our intelligent agent is desired of some properties and it wants to do something and in an environment, but the environment sort of disturbs and disrupts this robot, or in general, like it has to interact with the environment to be able to keep up and do its thing, right? It does it through sensing what is around it to get an idea, get a gauge of what is going on. Then it makes a decision what needs to be done next. And once it takes this decision, it uses its movement modalities or actuation modalities to be able to physically do what it needs to do, right? And this is the high school version. This is more like an understanding thing, but there are like more formal words which we use in robotics, right? And let's look at that in a second. So in the PhD version, which I jokingly call the PhD version, is basically how you would actually like write a research paper or like talk to a person who is in the field of robotics, right? Who is expert in this robotics domain. So the sensing modality we talked about before is going to be replaced by something called perception. In this particular little image, you see that there is an aerial robot. It's sensing the world through a depth map, right? It's seeing the world in how far something is, and it can basically get a gauge of, hey, what is around me? And the goal here is for the aerial robot to go from point A to point B without being able to without hitting any obstacles, right? And this is called the navigation problem in robotics. So perception is a little more advanced and nuanced than sensing. Sensing is merely receiving information about the world, and perception is more like one level cognitively higher, where you understand what this information even physically means, right? Like there's some physical understanding going on here. Then decision making becomes planning. In this particular case, remember, we are trying to navigate from point A to point B. So in the planning scenario, we are basically creating a path. Let me play the animation again. We are playing the animation wherein like we have this green colored path, which you see, which is a path in 3 dimensions, where you're traversing towards the goal, but you're not hitting any of the obstacles, right? And that's our planning scenario, and which we do this every single day. So then the last thing is basically control or actuation. In this case, you determine how the motor speeds have to change so that your robot can go left and right, go up and down, and adjust its position in 3D space with respect to the environment so that you reach the goal you desired in the beginning, right? And note that you are doing perception, planning, and control in a continuous loop, because the environment around you is changing. It's not a one-shot thing. You do this over and over again, generally like a few hundred times a second, depending on the kind of robot you have. So robots again are amazing, and they come in various flavors. So almost all of them have 3 distinct modalities. which feed into each other and they occur in a recursive loop, right? You start with perception, you get a sense of what is around you, then you do planning, you plan for what needs to be done next, and then you actually like execute this action through some control or actuation modality. Again, the kind of sensors, the kind of planning, and the kind of actuation depends on the task at hand or the set of tasks at hand. And there are different flavors of robots which you will see around you which can do these things in a completely different manner. Next time somebody asks you the question, is a washing machine a robot? You can really give them a good answer because you can define that a robot is defined in the particular way we just talked about. And in that definition, you can be like, hey, in my definition of robotics, yes, the washing machine is a robot. Or you can change the definition to adapt to your needs, and you can say, hey, the washing machine is not a robot. For the keen viewers thinking, hey, where does artificial intelligence go into these things, right? That's a beautiful question to think about in the day and era where we are surrounded by large language models and ChatGPT and Claude and things like that. AI can go in each and every one of these blocks, right? And there are research papers which do artificial intelligence into each and everything. For example, in the perception side, you saw that we are working with the depth map. You can just use a bunch of like low power sensors, combine them with a powerful AI system to obtain this depth map as an example. And then for the planning side, like you can have like the input of this depth map going into the planner, planning neural network, and the neural network basically spits out a set of locations, which is your plan of action, depending on what you want to do. And for the control side, generally there's a common term called reinforcement learning, which is basically used to be able to know, hey, how do I change the motor speeds in an intuitive manner for the task accomplishment rather than pure physical set of equations or math. And it's generally very useful for like really complicated systems which cannot be mathematically modeled, right? There's a lot of research ongoing right now which works on showing that, hey, like using a neural network in this particular way makes it robust to different kind of environmental changes, along with the fact that we can actually have bounds on safety, and we can sort of certify these kind of scenarios like just like a mathematical algorithm would be. And it's like an exciting time we live in today. We don't know what's going to happen in the future, but it sure looks very exciting. In the end, you should be able to see that like we know what a robot is, and we know what the building blocks of a robot are. We'll join again next time with a new topic. Take care. See you all. Bye.